Hiya, hello. Welcome. My first task for today is the same as always. Please move closer. I think it makes it a nice atmosphere. There's a few chairs left if you really need to sit down. Thank you very much. And can everyone hear me at the back? We have a mic now, those who weren't here last week. So we're just testing at the sound, but if it's too noisy, let me know, or just give me some kind of signal. Great, thanks. So welcome to July Satuccino. We usually apparently have a barbecue in the summer, but I think it's a good job we didn't today because the weather's a bit testy. My name is Joanne Oliver. I'm the business engagement lead here at the Catapult. So anything you need to do with Catapult, just give me an email and I'll do my best to help whatever you need. So today we have mostly the lineup in-person speakers and got quite a few variety here. We had some cancellations, so it might look a little bit different, but we had some additions as well last notice. But other than that, I'll hand you over to our first keynote speaker, which is Nick from UK CEH. That's yours, and that is all foods.
Okay, all right, thanks everybody. Okay, so well, I'm going to be slightly hyper here for a number of reasons. One, because I just am. Two, because an hour ago I was collecting water quality and water flow data on the Thames at Wallingford with a remote control boat, which was going slightly wrong, and so we were running late, which meant that when I got here, we had about 3 minutes for Jo to realise she hadn't got my presentation, and we had to transfer the 160 megabyte presentation. But anyway, hopefully it's going to work from here. So who am I? I'm a senior hydrometric scientist working at UK Centre for Ecology and Hydrology. I've just been turned down probably because I'm very loud. Is that right? Yeah, and so what's a senior hydrometric scientist do? Well, I muck about trying to measure river flow is what I do. So without further ado, we'll go into this. So this presentation is about the VSat project, which is a project that I've been leading on technically. And we're trying to establish if we can measure river flow from space. But the critical thing here is we're trying to use satellite video, which is something we're not aware that anyone else has done. So we're going to rattle through. I've got quite a few slides. So first off, why are we doing this? Because there is nothing more important than water. Without water, none of us would exist. Our businesses wouldn't exist. We'd have no food. We'd have no drink. We couldn't wash. Forget oil. Water is where it's at. It's important. And floods. So floods are the most costly natural disaster. When you look at an event like this, which happened in Turkey in August 2021, and consider trying to measure this, trying to quantify this. Is there a pointer on here? I don't know. It's really important. If you tried to measure that with traditional techniques, you could end up dead. It would be life-threatening, very, very difficult, and very hazardous. But understanding those flows is really important. Equally important, water resources. We just touched on it. The value of water, water for drinking, water for production of food, water for industry. This slide, I found this is from the NASA website of Earth observation images. But it's really nice. You can see how Lake Mead has got way, way smaller for a period of drought. So if you look on the right-hand side, you can see it's got way, way smaller. But the people who need the water has got way, way bigger. So we've gone from 500,000 people to 2.4 million, and the volume of water available for those people has diminished enormously and has been continuing to do so. So the management of water really is of critical global importance. And monitoring networks. So all around the world, every country in the world tries to monitor its water. We're pretty good at it in this country. We have an established network, but this is what happens when a big flood occurs. This is the monitoring station completely destroyed by Storm Desmond in 2015. And you can see the little arrows point to where it used to be in that aerial image. And then you can see here the erosion, the destruction of the land around the river there. So very hazardous kind of place to be. So we're trying to solve that by taking an overview from further away. So just to add to this, climate change, it's happening, it's going to be bad, it's going to make everything worse. The floods are going to get bigger, water as a resource is going to be more scarce and under more pressure, so it's going to be a challenge. So what are we trying to do to overcome this? We're trying to come up with a method of understanding how much water is in rivers, and rivers are of course the artery around which water flows all around the world, and we're trying to come up with something that we can do anywhere on the planet at relatively low cost and give us good results. So what we're trying to do is we're using video shot from space by satellites to try to show us the speed of flow of the water's surface. So there have been previous pieces of research into measuring rivers using satellites, but they tend to just look at the height of the water surface and the extent of the river if it's flooding and into the floodplain. We're actually looking at the flow speed, which is to our knowledge is new and brings an enormous benefit to accuracy and the potential of this method. So here is a video which Joe will now try and play for me. So what we're doing, if the video will play, what we're doing builds upon an established method. So we've known for some time that if we fly a drone like this one, I brought a prop for you to see, it's nothing special. This is a drone you could go and buy from Argos, from Jessop's, costs about £900. If you fly that over a river and shoot a video, you can work out the speed of flow, and it's really quite simple. Will it play again? By the time I get to talk about it, it's stopped. But you can see the flow of the movement of the water there. So what we're doing with our Nadia view video, we're just trying to scale. So we need to know the width of the river, we need to give a dimension, and then we're scaling the movement from pixel coordinates to on the ground coordinates. And so we had the thought about 5 or 6 years ago, we can do this from a drone. Why can't we do this with a satellite? We were aware that Planet Labs, who may appear in my next slide, no, a couple of slides further on, could do this. So we thought, well, if we can do this with a drone, why can't we do it from space with a satellite? Then we can get to way more places and get way more data. So that's the principle. Basically, just looking from a higher vantage point and applying exactly the same processing, exactly the same methodology. So Planet Labs SkySat Constellation is what we're using. There's 21 of these things. So, and they can shoot very high resolution. They're about 0.5 meter pixel sizes. It's full HD, better than full HD, 2560, I think, by 1080, 30 frames per second. But crucially, multiple daily revisits. So most science presentations about measuring things, they say, yeah, it's great. Sentinel came back 10 days later, and we can get 7 observations a day. And proof, this is the River Tweed on the boundary between England and Scotland. 4 observations within about 23 hours of each other. So that means we can get near real-time information from this. So anybody who does have any kind of hydrology background or river measurement background will know that you can't actually work out the flow of a river just by looking at the speed of the surface. So that's very true. So what we've been doing to validate and test our method, we've taken out the acoustic sensor on the boat. This is what I was playing with just an hour ago at Wallingford Bridge. It gives us this wonderful map of the depth of the river and also the water speed. So water speed is represented by color. The fastest water is this stuff here in the middle, as you might expect, towards the top, and it gets slower towards the banks. So we've also been flying the drone, this one right here, to collect validation data that's more directly comparable. It's comparing video results with video results. This is a video from space. I hope I don't mind me showing this. We have spoken to them a number of times, but when it plays, you will notice you should focus on this area here and this area here, and you can see the flow of the water. So it's not that impressive in terms of, wow, I was expecting to see something like your drone video, but this is shot from 450 kilometers up. So it's pretty incredible. The other thing you might notice, the dynamic cropping. So when we get these videos, they're not that stable. We have to stabilize them. We also have to georectify them because the viewing position changes through the 30 seconds that the video is collected. But yeah, we can see the flow. This is just downstream of Victoria Falls on the Zambezi, and this will process really well. So yeah, what can we do with this? Here's a real world application. The Pakistan floods of September 2022. Planet were able to obtain a total of 6 videos for me of this location. Again, this is really mind-blowing stuff for hydrologists. We could not just do measurements in one location, we could do 3 or 4 locations in the same video, because the footprint of the video on the ground is about 1 kilometer by about 2.5. So within that, we can self-validate, we can self-check. We couldn't get out there and fly our drone, we didn't have the budget to go do that, but we can see very similar results from each of these 3 locations. We can also see the distribution of flow is matching what we would expect as it comes around this bend. And we also know from experience that the values we see here are bang in line with what we would expect. So we're really, really impressed with these results, really quite blown away with it. So where have we got measurements so far? This is where we've got observations so far. We've got several in Scotland. We've got some in Ukraine. We managed to get something in Ukraine for the dam breach. Australia, one of our project partners is in Australia. We've got some really nice stuff up in the Yukon. We've got ice breakup. We can video of ice chunks going down the river. So benefits, I think I'm getting to the end now. Large rivers and flow measurements pretty much anywhere in the world. Of course, cloud cover is an issue, which I think I come on to in my last slide. No people or equipment needed on site. So you have the hassle and the cost and the danger of getting people there and the challenge of getting them there when an event is actually happening, like the Pakistan one. We couldn't get there to do a measurement if we wanted to. Multiple daily repeats, that's a really big deal for us. Validation and real-time training of global hydrological models. So there are lots of models that try to predict the availability of water, the movement of water, the impact of floods, but it's very difficult to get validation data. So those models can be improved greatly by this result. And finally, it's cool. I started doing hydrometry 33 years ago, I think, and that involved standing in a river. The water would be up to my waist, up to my knees. I'd be cold, I'd be wet. I had a little propeller on a stick. I was trying to write numbers in a little book, which would disintegrate in the rain as I tried to write it. And now we're doing it from space. So what it's done is really built the profile of what we're trying to do, and that's been really significant. So problems and challenges, I will have to look at my slides to remind me these. Clouds is the big one. It doesn't work through clouds. You know, it's optical, can't see through clouds. We would like to experiment, see whether we can do this with any kind of radar system, any kind of radar technology. Optimization of imagery. We do have a workflow that optimizes the imagery, that stabilizes it and rectifies it, but it's not that slick, so we need to improve that. Yeah, related to that, the workflow is quite time consuming. It's taking us a few days to get a result at the moment. We want to get it down to a couple of hours, maybe a few minutes. Ground-based information. So that's one I showed you of Pakistan. We could see the surface velocity. If we had a cross-section of the river already, we could actually calculate discharge. So if we can get more ground-based information for key locations around the world, that can really make a difference. Money. We've hardly got any money. This project was sponsored by ESA. We're very grateful to ESA. I see a nice ESA t-shirt there. We're very grateful, but it wasn't a lot of money. So we didn't have a lot of money for validation and so on. So yeah, we are always keen on more money. The other thing we need really to enable this to work remotely with nobody there, we do need to know the surface height. We can get that from altimetry missions like SWAT, the NASA SWAT mission, which is trying to observe the height of water around the whole planet. But it doesn't have the revisits. You know, we'll often have several days separation between our observation and what we could get from that. Getting into the closing phase out. Pelican, what is Pelican? Planet Labs are launching a whole new constellation this year. The SkySats are 7 or 8 years old. They're amazing, but they're quite old now. So we're going to have improved resolution. We're hoping improved stability. We hope very much we'll have video. We don't know at this stage, but we really hope that we do. And yeah, finally, this is my final slide at last. Yeah, I think this is the most exciting advance in hydrology in my lifetime, although I might be biased. And that's the end. Thank you.
Thank you very much, Nick. I thoroughly enjoyed that. So we'll head over to now our 60-second pitches, starting with Tal from Sat Tracker. All yours.
Yeah, thank you. Thank you, Joanna. Yeah, 60 seconds, it's challenging. Yeah, my name is Tao Huang, and actually I'm presenting here two business. The first one is the tracker, satellite tracking antennas. What we do is to develop innovative tracking antennas for the LEO or MEO orbit satellites to provide broadband internet services to the million people in the world. In simple way, that system is similar to the Elon Musk Starlink. I'm sure everybody knows that. But we are providing low cost, high performance tracking antenna solutions. So what I'm here also is also mentioning the other business take up consultants, where we providing consultancy and also product designs for RF radio frequency signals, EMC, EMI antenna services. So if you need to solve the problems of your satellites or other telecommunication equipment in EMC, EMI, or link budget, or providing antenna solutions, do please get in touch. Get into our website, you will see all the contact details. I love to hear from you. Thank you.
Thank you. And next up, we have Simone from the Catapult.
Hi, I'm Simone Hollis. I'm head of Plus Growth here at the Catapult, and I'm here today to talk to you about the Investor Launchpad. So start up, grow and innovate. That's how you, our space enterprise community, are increasing the value of the space sectors to the UK economy. And hopefully you're already members of the Space Enterprise Community Platform, and the sister site we are launching now is the Investor Launchpad, which showcases the breadth and depth of capabilities of the UK space sector globally. We have 6 thematic capability reports that have been gathered, as you see here, from space sustainability to Earth observation with Earth and climate intelligence. And we have some webinars coming up on the 18th of July to bring actors from Department of Business and Trade and also from our cluster ecosystem to showcase the capabilities across the UK to do business for foreign direct investors, and also for those of you who are interested in doing international collaborations and working with businesses across the globe. So I encourage you to look at what you can do by looking at the Space Enterprise Community Platform and our Investor Launchpad.
Thank you very much. A great resource there. Moving on now, do we have Adrian? I don't think perfect. Thank you very much.
Here.
There you go. So yours. Thank you.
So hi, my name is Adrian Clement, and I'm a venture manager at Creative Destruction Lab, which is a commercialization program based out of the University of Oxford. We've had a space program that's been going on for a few years at some of our sister sites in Canada, the US, and France. And Oxford is joining into that for the fall. So we are looking for 40 early stage space companies to join the program. Applications are open right now up until the end of July, and companies that are admitted to the program will receive mentorship from mentors like Chris Hadfield, who is a former commander of the International Space Station, and Chad Anderson is a US-based space VC. So if you are an early stage space company or you know any, feel free to look us up at Creative Destruction Lab or add me on LinkedIn and use something. Thank you.
Thank you very much. I'll have to grab some more info so we can put it on the Space Enterprise community later. And as always, all the slides and information will be sent out afterwards if you miss anything. And next, I'll bring up Simon from Satuccino. Make your way all the way from the back.
Thank you.
Else.
Thank you. I'm going to tell you a few truths that you know already, but they're quite insightful. Most people don't leave a bad company. They leave bad management, bad leadership, and bad culture. Professionals like us, intelligent professionals, want 3 things from the workplace. We want a sense of growth, that we're growing and getting better. We want a sense that our work is meaningful, that it has some kind of purpose. And we want to feel like we're our own boss, that our intelligence can be applied in the workplace. No one is telling us what to do. Hands up if you like being told what to do. We've gone past that stage, with one exception. So, Acetoma is a business that's designed to create a leadership culture where the leaders of the business are creating an environment where people have more to give, more energy to give it, and actually more aspiration to keep on giving it. It helps with productivity. It helps with retention, which is a big issue in the industry. And it helps with innovation. So if you want a more productive, leadership-driven culture, then please come in touch and let us explore together how we can create an environment that everyone wants to stay in. Thank you.
You can stay there and just keep talking. Thank you very much. A few more in-person people next. And we have Luz from Latin Business. Thank you very much.
Thank you, John. Good afternoon, everyone. My name is Luz Jaimes, and I am the founder of Latin Business. Latin Business is a UK-based consultancy helping tech businesses going into Latin American market. I came today because my friend Nushin invited, and Nushin herself has been in Latin America in some projects from Catapult in Chile and Colombia, where I am originally from. There is from first-hand experience the needs and demands of high technology that is being produced here in the UK. So I have created this business to serve as a bridge between the both regions. And there is the eyes of the world are starting to be focused on this area at the moment. And these are the good news. And the reasons are because there is 25% of natural resources of the world located in Latin America. And this includes water and cultivable land, and of course, lots of sun and wind, which is free. And the UK government is already took attention of this and is wanted to improve this number of 22 billion of import-export between the two regions, and is creating like focusing on commercialization between the Latin America and the UK. And last but not least, there is lots of people over there. There is 33 countries, 650 million. The third more spoken language in the world, which is Spanish and Portuguese. So my core offer to the UK tech businesses is to help you to save time, to scope and do the market research and do the work for you to see if there is a market of your services or products. I help you to address the risks if all the fame of Latin America has scared people out from not all the Netflix media. And then finally, I tell you that one of the things that people who have long businesses in Latin America have found is the people, because people buy from people. And so I'm pleased to know that to make businesses in Latin America is enjoyable. And you will like to know that they also have a good sense of humor. But I cannot demonstrate this today because time is over. So thank you very much.
Thank you very much. Maybe we can have a keynote next time. So we'll head over to Ian from Astound Studio next. If you're in the room, great.
Thanks very much. Afternoon, everybody. So you all have amazing technology, ideas, and expertise that you all want to talk about. But when you get in front of your stakeholders, very often we just default to that linear, lifeless slide deck, which doesn't really do justice to the work that you do. So I'm Ian Woodley from Astound Studio, and I work with innovators, technical leaders, advanced manufacturers, really helping them to showcase their expertise through next generation interactive digital presentations. So our PitchFlex platform delivers an engaging customer experience like never before. We bring together offline video, animation, motion graphics, and the ability to move from overview to detail at a tap. You can choose individual content at will, so you can tailor your delivery to a different audience, different every time. And really, the end result is to deliver a greater understanding of your technology and your innovation. So it transforms those customer conversations across your whole stakeholder audience. Thank you very much. Great to see you. Thanks for your time, and be good to connect. Thank you.
Thank you very much. And last in person, we have Matt from RAL Space.
Is there slides?
Oh, good, yeah.
I'm Matt from RAL Space. I'm a test engineer. So some of you might know RAL Space provides a series of testing facilities. The one I want to focus on today is our shock testing. So it's really been new compared to other facilities. However, we have been operating it from coming up to 4 years now. Where we've developed our machine, so that's it in the bottom right. It's pneumatic gun-driven impact, and that is ECSS accredited. We can fit on small CubeSats or instrument level testing. So the picture on the left there is an example of a CubeSat that we had. We do 3 axes, and we do this for SRS testing. Yeah, if you know about shock testing, you understand what that is. And we can get most very good results. You can see in the top right there. Yeah, if you have any questions, you can either contact me or Dave Rippington if you want to do vibration testing as well. Thank you.
Thank you very much. From a layperson like me, I don't think I really understand it, but maybe I'll ask you some questions afterwards to share it with everyone else. And lastly but not least, we have Esther from the Satellite Applications who should be joining us online.
Yeah, I'm here. Do you have maybe the PowerPoints?
Yeah.
Okay, thank you. Okay, can you hear me correctly?
Yeah, all good.
Okay, well, thank you for the introduction, Joanne. So hello, everyone. My name is Esther, and I'll be presenting to you our robotics facility at Westcott. So on the top picture, you can see our in-orbit servicing and manufacturing facility or yard. I'll call it IOSM because it's shorter. It has 2 large robotics arms, which could be compared to the propulsion system of a spacecraft. So with the idea of the robotics arm representing the propulsion, you could mount on them satellite mockup, over robotics arm, over technology, or camera system, for example. So our in-orbit servicing manufacturing yard has multiple capabilities where we can test in-orbit missions rather than individual component testing. So for example, we have close proximity operation, refueling capabilities, docking. We also had some clients mounting their satellites to take as much data as they could to then train their model to recognize the satellites. So that's the ISM yard. And on the bottom picture, you have our robotics lab, which is a bit smaller, and we can do teleoperation and force control of the robotics arm behind. We also have digital simulation, and we're continuously working on new technologies such as VR control of the arm. So if you're interested, or if you know anyone else who is interested in using our facilities, feel free to reach out to us. And I think that's my 1 minute gone, so thank you for listening.
Thank you very much, Esther. Now I have moved the lights. Aha, ta-da. The last slide, I just wanted to double check everyone was aware, especially the newbies who are new to Satuccino, of the space enterprise community. So I'm aware that Satuccino has been going for 10 years now, pretty much since the inception of Satellite Applications Catapult. And so is Satuccino. So we're in the 10th anniversary now. And this is something that we've added during lockdown, and it's a great resource to show everything that has been spoken about today. So if you missed anything, it will all be on there. And if not, just send me an email. We've got a follow-up email that gets sent out as well. Otherwise, thank you to all the speakers, especially Nick. Nick came to me a few months ago at a different Satuccino and said, there's not enough scientists here telling about the science. I thought that was a really great idea, and it's so good to have variety at an event like this. So if you have anything that you want to add, or you know somebody that would be great to just show what you're doing in the industry, then please do come along and share, and the more the merrier. Thank you very much. See you in September.